So there are a few questions pending remaining from the previous problem sheet. We'll come to that. Before that, let's go to a new topic. New topic as in we were discussing linear functions. So we are going to discuss a very important aspect of linear functions. Please listen carefully. Okay. This is a very important idea. Okay. We have already seen that a linear function will be of the form, say, f of x is equal to, say, 2x plus 3, 5x plus 5, 7x minus 11. All these are linear functions. So in general, a linear function will be of the form f of x is equal to mx plus c. mx plus c. So what does f of x mean? F of x means the y value, the output value. Basically, if this is your function, you give x as the input, you get f of x as the output. For example, if you have f of x is equal to 7x minus 11. 7x minus 11. So this is your function, 7x minus 11. If you feed x is equal to 2 to this function, the output is actually represented as f of 2. Okay. F of 2 means what? The output corresponding to the input, x is equal to 2. Right. And that will be given, that can be evaluated using this expression. So f of 2 is going to be 7 times 2 minus 11. So this is 14 minus 11, which is 3. Right. So this is the basic idea. This you already know, right? Yes. Now, what I'm going to discuss today is about the significance of the number 7 and number minus 11 here. Okay. What does it signify? Okay. So, as we saw, in general, your f of x will be of the form mx plus c. Another way to write this relationship is y is equal to mx plus c. Y is equal to mx plus c. So your x is the input variable, y is the output variable. Okay, m and c are two constants. Okay, depending on m and c, you keep getting different linear functions, right? So please listen carefully. This term is called the slope of the linear function. Slope of the linear function. And this term here is called the y-intercept, or simply intercept. Okay, if somebody simply says intercept, it means what? Y-intercept. Okay. So please note down these two terms. I hope you've heard about these two terms. One is slope, another is y-intercept. Slope and y-intercept. Slope and y-intercept. Now, say if I have y is equal to 7x minus 11. This slope is 7. And we know this is usually represented as m. And c value is equal to y-intercept. That is equal to minus 11. Minus 11. Yes. Now we are going to see the significance of the numbers 7 and minus 11. Okay. Let's see the significance of the number 7 and minus 11. Please listen carefully. Please listen carefully. I'm going to take this example. And then we are going to see the significance of the number 7 as well as minus 11. Right. So let us say we are going to create an input-output table, a list of some inputs and some outputs. So if I'm going to give 0 as the input, your output will be, tell me what is the output? If you put x is equal to 0 as the input, the output will be, it will be, hello? If you put x is equal to 0, the output will be, are you with me? Yeah. If you put x is equal to 0, the output is going to be, in this particular function, if you put x is equal to 0, your y value is going to be, just put x is, yeah, it is going to be minus 11. Yeah, right. Now, if I put x is equal to 1, if I put x is equal to 1, put x is equal to 1, your y value is going to be 7 minus 11, which is minus 4. Now, if you put x is equal to 2, what happens? The output is going to be y is equal to 7 times 2 minus 11, which is 14 minus 11, which is 3. Now, if I put x is equal to 3, now if I put x is equal to 3, your y value will be 7 times 3 minus 11. So 7 times 3 minus 11 is 10. 10. Now, if I put x is equal to 4, your y value is going to be, put x is equal to 4, your y value is going to be 7 times 4 minus 11, which is 28 minus 11, which is 17. Right? I've just taken some few values of x, and now we are going to discuss what is the significance of the number 7 and the significance of the number minus 11. And it's very clear that minus 11, the number minus 11 here is nothing but, this is what we call as the intercept, right? Y-intercept. It is nothing but the input value when the output value when the input is 0. Okay, see, do you observe this? Do you observe this? Minus 11 is nothing but the input value, the output value when the input is 0. Okay, you can call this as the initial output. Initial output. Okay, when the input is 0, the initial output is nothing but your y-intercept. Right? Now, what is the significance of the number 7? What is the significance of the number 7? Do you see the significance of the number 7 anywhere in this table? Please have a look and let me know. Do you see any significance for the number 7? Please have a look at the table. Just observe it and let me know. There is something very remarkable about these numbers. There is something very remarkable about these numbers. Can you tell me? Do you see any pattern in the output? Yeah. My question is simple. Do you see any pattern in the output? The input values are increased by 1. Okay, the input values are increased by 1 unit. There is a pattern in the output. What is the pattern in the output? What is the pattern in the output? Yeah, it keeps getting added with 7, right? Yes, exactly. Yes. Yes, exactly. Robin, see, if I keep incrementing the input by 1 unit, 1 unit, 1 unit. Here it's 1 unit. Going from here it's 1 unit. Going from here it's 1 unit. And here the output keeps getting changed by plus 7 units, right? Is that a coincidence? No. No. It is not a coincidence. It's decided by this number 7. It is decided by the number 7. Right? So the idea is very simple. Okay. When you increase the input by 1 unit, how much does your output change? When you increase the input by 1 unit, how much does your output change? When you increase your x value by 1 unit, how much does your y value change? That is the significance of the number 7 here. Is that all right? Is that all right? So your m is nothing but change in y value when you make the change in x value as 1. Right? Is that clear? Yeah. So I'm going to write my m as, your m is equal to change in y, delta y. I am going to write it as delta y. Change in y is delta y. Delta represents the change. Okay, change in y when delta x is set as 1. So this is the significance of your m. Okay, your m. M is this number 7. Hope this is clear. Change in y when change in x is set as 1. Yes. So far so good. Please tell me. So far so good. Yeah. Now what happens if delta x is not 1? Let's see that as well. Okay, suppose the delta x value is not 1. We are going to take the same function, which is y is equal to 7x minus 11. Y is equal to 7x minus 11. But instead of choosing the inputs as 0, 1, 2, 3, 4, I'm going to choose the inputs as 0, 2, 4, 6, and 8. Okay. Instead of changing the input by 1 unit, I'm going to change the input by 2 units. Okay. Every time I'm going to increase the input by 2 units. Let's see what happens to the output. Now, when you put x is equal to 0, this is going to be minus 11. When you put x is equal to 2, your y value is going to become 3. When you substitute x is equal to 4, it is going to be x is equal to 4. Your y value is going to be 4 times 7 minus 11, which is 28 minus 11, which is 17. Yes. And when you put your x value as 6, when you substitute x value as 6, your y value comes out as 7 times 6 minus 11. So that is 42 minus 11. That is going to be 31. And when you put your x value as 8, your y value is going to be 7 times 8 minus 11. So this is 56 minus 11. That is going to be 45. Now what you have done is, you're varying the input by 2 units every time. Now, what happens to the output? Is there a pattern in the output? Is there a pattern? Is there a pattern in the output? Do you see any pattern? Just have a look at these numbers, the second column here, and let me know if there is any pattern here. Anything significant, anything remarkable? What happens when your input goes from 0 to 2? What happens when your input goes from 0 to 2? Your output goes from minus 11 to 3. So that is a difference of 14, right? 14. There's a difference of 14. Now, what happens when your input goes from 2 to 4? 2 to 4. When your input goes from 2 to 4, what happens to your output? What happens to your output? Output goes from 3 to 17. That is an increase. Yeah, it goes up by 40. So here, every time it was changing by 2 units, plus 2. This is plus 2. This is plus 2. This is plus 2. And here it is plus 40. Here it is plus 40. Here also it's plus 40. Here also it's plus 40. Can you see that? Don't you see that? Don't you see that? When you change the input by 2 units, your output changes by 14 units. Do you see that? Tell me, please tell me. Please tell me, do you see that? Do you see that your output goes up by 14 units every time you change the input by 2 units? Everyone? Yes? Yes? No? Yes? Yes? Now tell me this. Does 7 have any role to play in this? Is this just coincidence? Is this just coincidence? No, right? Okay. Now understand that the ratio of change in y, change in output by change in input. This ratio, this 14 over 2 ratio is nothing but 7. Okay. So the ratio of change in output by change in input is nothing but your 7, right? Okay. So here we see that your 7 was nothing but your change in y by change in x. Change in y by change in x. Okay. So this is your m. Note this down. Now, is this consistent with our previous observation? Is this consistent with our previous observation? Yes, definitely, because in the previous case, your delta x was taken as, in the previous case, if you consider this expression delta y by delta x as m, in the previous case, your delta x was chosen as 1. Then this came out to be 7. In this particular case, when your change in x was chosen as 2, this came out as 40. So what we have just observed is consistent with what we have seen before. Okay. And your m is nothing but, the number 7 in this case is nothing but the ratio of change in y over change in x. Does that make sense? Does that make sense? Yes. Right? Yes. So what really happens here, see, mathematically that is clear, it's a ratio. But physical, what is the physical significance? See, what is the physical significance? You're incrementing incrementing the input by 1 unit. The output keeps getting changed by 7 units, right? So we can call this as a rate of change, right? Rate of change of output with respect to the input. It's the rate at which y changes with respect to x. So that is the physical significance. Okay, that is a physical significance. That is the rate at which y value changes. Your output value changes when you change the input by 1 unit. Yes. So that is the significance of the number 7. The number 7 is the coefficient of x. Okay, coefficient of x. What is the significance of the number 7? The number 7 gives the ratio of change in output over change in input. Okay, that is a mathematical meaning. In a physical sense, it gives a rate of change of the y value, the output value with respect to the input value. Let us take some physical scenario. Suppose you are driving at a speed of 7 miles per hour. Okay, you're traveling at the speed of 7 miles per hour. Okay, your speed is 7 miles per hour. Okay, you can write your distance as 7 times t. Your distance covered is 7 times t, because in 1 hour you'll cover 7 miles. In 2 hours you'll cover 14 miles. In 3 hours you'll cover 21 miles. In t number of hours, how much distance will you cover? In t number of hours, 7 times t, right? 7 times t. 7 times t. Does that make sense? In 1 hour, we are going to cover 7 miles. 1 hour, 7 miles. 2 hours, it's 14 miles. 3 hours, it's going to be 21 miles. Yes. In t number of hours, it's going to be 7 times t miles. If your speed is 7 miles per hour. Does that make sense? Does that make sense? Yeah. So if you make a table, say, if you make an input output table here it is the input t, the output t. 1 hour, you're traveling 7 miles. 2 hours, it's 14. 3 hours, it's 21. 4 hours, it's 28. 5 hours is 35. Okay. So how much time do you travel in 1 hour? That is your speed, right? Speed is nothing but how much distance will you travel in 1 hour? If you travel 7 miles, your speed is 7 miles per hour. So that is nothing but the rate of change of distance with respect to the time. Okay. The rate at which you are covering a distance. The rate at which you are covering a distance. In other words, it is the ratio of change in distance over change in time. Okay. When change in time is 1 unit, it is nothing but change in the distance. Right. So this is a very simple physical scenario. Very simple physical scenario. There is no constant term here. There is no y-intercept here. There is no y-intercept here. It's just the number 7 here. But the significance of the number 7 is nothing but it represents the speed. It represents the speed. Or in other words, it represents the rate at which your distance, your output changes with respect to the input. So significance of 7 is nothing but the rate at which your output changes with respect to your input. Is that clear? Yes. Yeah. So what we just saw is, say if I have something of the form y is equal to mx plus c, your c is nothing but initial input. Okay. We have seen that c is nothing but initial input. And this is what we call the y-intercept. Okay. This is nothing but the input when, sorry, it's not the initial input, it's the initial output. Sorry, I'm sorry. It's the output when input is equal to 0. Okay, so that is the significance of the number c. 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 For example, let's take another example. Suppose that you already have $100 with you and you are saving, say, $7 every day. You already have $100 to begin with. Now you save $7 every day. Okay. You have $100 with you to begin with. You save $100 to begin with. You save $7 every day. Now, how can you represent the scenario as a mathematical equation? At the end of one day, you will have 100 plus $7. At the end of second day, you will have 100 plus $14. At the end of third day, you will have 100 plus $21. At the end of n number of days, okay, the money you will have is 100 plus 7 times n. Is that clear? Yeah. Now, what is the significance of the number 100? What is the significance of the number 100? It's the initial money you have, right? So this is like an input-output relationship. This is like an input-output relationship. So if I have n as the input m as the output. This is the number of days. Number of days. This is the money you save. See, when n is 0, to begin with, you had $100. When n is 1, at the end of 1 day, you have $107. At the end of 2 days, you have $140. At the end of 3 days, you have $121. It's 128. See this table? So what is the significance of this number 100? What is the significance of the number 100? It is the initial output when there is no input. Yeah, cool. Simple as that, right? And what is the significance of the number 7 here? What is the significance of the number 7 here? When you change the input by 1 unit, the corresponding change in output is your 7. Got it? Yes? Or otherwise, you can say that if you change the input by 2 units, your output will change by 14 units. 14 units. 14 units. So what is the significance of the number 7? It's change in M, the output, by change in input. So the number 7 here is change in output by change in input. And then significance of the number 100 is the initial output when there is no input. Is that clear? Is that clear? See, that is the significance of the numbers m and c in a linear function. You have to clearly understand this because there are a lot of questions that comes from this, and in those questions they will give you a physical scenario, a real world scenario, and you will be asked to interpret the significance of the m, significance of the number m, significance of the number c, etc. Okay. Yes, is that okay? Is that okay? Is that okay? Yeah, cool. So what we just saw is if we have something of the form y is equal to mx plus c, this is your input output mechanism. This is your input x, your corresponding output will be mx plus c, and this is assigned as y, your y is equal to mx plus c. This is the function. Now your c is nothing but y-intercept. Okay, this is the y value when x is equal to 0. Your m value is nothing but delta y by delta x. Delta y by delta x. Change in y value by change in x value. Change in y value by change in x value. Change in y value by change in x value. Change in y value divided by change in x value. You can also say that this is nothing but change in y when change in x is 1. When change in x is given to be 1, your m value is nothing but change in y. Okay, because the denominator is 1, the denominator is 1, it is nothing but change in y. Make sense? Make sense? Yeah. See, what do you think is the most remarkable thing about linear functions? We have seen several examples. What do you think is the most remarkable thing about the linear function, the linear relationship between x and y. There is something very remarkable here. Very remarkable here. You know, this m value or the change in y over change in x is a constant. It does not change. If you take different pairs of points, say if you're going from this to this, or if you're going from this to this, okay, you take any two set of pairs, any two pairs, any two input outputs, ordered pairs. Your change in y by change in x will always be the same. It will not change. It will not change. It will not change. So for example, see this. If you go from this situation to this situation, listen carefully. You are going from this situation. When the input is 0, output is minus 11. So you can represent it as an ordered pair 0, minus 11. Now 3, 10 is this. Can you tell me what is change in y over change in x? Delta y by delta x. Delta y by delta x. What is the number? What is the value? Delta y by delta x. What is the value? Delta y by delta x. When you're going from 0, minus 11 to 3, 10, what is the change in y? What is the change in y when you go from minus 11 to 10? When you go from minus 11 to 10, what is the change in y? No, it's not 11. You're going from minus 11 to 10. You're going from minus 11 to 10. Minus 11 to 10. It's 21, right? It's 21. Your delta y is 21. Change in y. What is your delta x? Your delta x is 3. Yes. Now, what is your delta y over delta x? It's 7. See, it does not change. You pick any two ordered pairs, or you pick any two entries from the input-output table. Your delta y by delta x will not change for a linear function. That is the most remarkable thing about linear functions. You get what I'm saying? You take a linear function, you take any two rows, or you take any two ordered pairs from the input-output relationship, and you calculate change in y by change in x, delta y by delta x. This ratio will be always the same. This ratio will always be the same. You get what I'm saying? And this ratio is what we call a slope. And this ratio is what we call a slope. And in physical scenario, physically, what does it mean? It represents the rate of change of y with respect to x. Rate of change of y with respect to x. Rate of change of y with respect to x. So your slope is nothing but the constant rate at which your y is changing with respect to x. It's a constant rate at which your y is changing with respect to x. So that is the intuitive meaning, intuitive understanding. The constant rate at which your y is changing, your output is changing with respect to your x, the input. Okay. So this is a very important thing. You have to understand it clearly. Okay. Because majority of the things that you'll encounter is a linear system. Okay. A lot of things that you encounter in real life. Okay. Is a linear system, and that can be modeled by a linear equation or a linear relationship between the input and output. And you have to clearly understand what is the meaning of your m. or the coefficient that is being multiplied on the input. Okay, coefficient that is being multiplied on the input. Yes. Cool. Now, this is not the case for other functions. Say, for example, suppose if I take some other function, say y is equal to x squared plus 3. Y is equal to x squared plus 3. Is this a linear function? Is this a linear function? Is this a linear function? This is not a linear function, right? This is not a linear function. This is not a linear function. Let's try to create some input-output tables. So if I have x values and y values here, let's write some values here. For 0, it is 3. For 1, it is 4. For 2, it is 7. For 3, it is 12. For 4, it's 19. For 5, it's 28. Now see this table. See this table. Do you see a similar pattern? Do you observe a similar pattern like we saw in a linear function? Do you see a similar pattern? Do you see a similar pattern here? Is there a similar pattern? Just like in linear functions? No, no, right? There is no. See, if your input changes by 1 unit every time, your input changes by 1 every time, but what happens to your output? See, here it is plus 1, here it is plus 3, here it is plus 5, here it is plus 7, here it is plus 9. Okay, it's not the same. It is not the same. Okay, when you give what do you say, equal constant changes in your input, constant changes in your input. Okay, the output, the change in output is not a constant. So this does not represent a linear relationship between x and y. Okay. So how do you know that a situation, a physical situation, represents a linear relationship? You keep giving constant changes in the input. If the output also changes at the constant rate, then you can say that it's a linear relationship. Yeah. Got it? A lot of situations that we encounter in every day will be actually a linear relationship between input and output. In general, a lot of the situations that we encounter. Okay. In general, that is the situation. Is that clear? Is that clear? Yeah. Now, one more thing I want to make clear is sometimes the function will be represented in this form. Instead of y is equal to mx plus c, they can give it in this form. F of x is equal to mx plus c. F of x is equal to mx plus c. In this case, as he said, c is nothing but your f of 0. What does f of 0 signify? F of 0 signify the output value, the function value when your input value is 0. When your input is 0, what is the output? Yeah. And what is your M value? Your M value will be your change in Y value over change in X value. So you have to remember that a linear relationship can always be represented in this form. A linear relationship can always be represented in this form. A linear relationship will always be represented in this form. So okay, this is nothing but your Y. Okay, this is nothing but your Y. This is nothing but your Y. Okay, your Y value can always be represented as some constant times X, and that constant is nothing but the rate at which your Y is changing with respect to X, plus another constant. That another constant is the initial value of the function. Okay, let's quickly see one example. Let's see how you can see. In the previous classes, we have seen tables representing linear functions, but we never use the table to arrive at the expression for the function. Now let's see how we can get the expression for the function. Let's see one example. From the table, how can you find the expression? The other way, you already know. If you know the expression for the function, you know how to generate a table. But if you have a table, how do you generate the function? If you have a table, how do you generate a function? If you have a table, how do you generate a function? So that is our question. Yeah. So let's see one table here. Some input output table here. X, Y, minus 1, 2, 0, 3, 1, 4, 2, 5, 3, 6. Can you tell me the relationship between Y and X? Y and X. It is given that this is a linear function. It is given that it's a linear function. Then can you tell me that? Can you tell me the relationship between Y and X? Please take some time, no problem. But I would like to get answer from everyone. Take some time, no issues. No, I want the relationship between Y and X. What I'm asking is the relationship between Y and X. So what is that function expression that represents Y? Y as a function of X will be a relationship between. Yeah, Anjali has given me an answer. What about others? Others, could you give me an answer? Others, could you give me an answer? Yes, very good, very good. Okay, now listen carefully. What is the logic here? What is the logic here? See, first of all, it is given that it is a linear relationship. Even if it's not given that it's a linear relationship, you can figure out that it's a linear relationship. Why? Because when you keep changing the X value by a constant number, see, this is plus 1, plus 1, plus 1, plus 1 everywhere. Your output also changes by plus 1, plus 1, plus 1, plus 1, right? So this is a linear relationship. Linear relationship. So you can write it as some mx plus c. Okay, you can write it as some mx plus c. Okay, and what is the c value? C value is the output value when your input is 0. So look at this. When your input is 0, That is C is equal to 3. When your input is 0, what is the output? Look at that. That is 3. Now, what is your M value? M value is nothing but change in Y by change in X. See, everywhere you see that when the change in X is plus 1, the change in Y is also plus 1. So it is plus 1 over plus 1, which is 1. So your Y value is nothing but 1 times X plus 3, which is X plus 3. I mean, in this case, you don't have to do all these calculations because it's very clear, very obvious. To get output, you add 3 to the input. To get output, you just add 3 to the input. That is how the table is generated, right? I'll give you one more example. I hope the procedure is clear because that is the general way of doing things. I'll give you one more example. Can you tell me what is the relationship between X and Y in this case? What is the relationship between X and Y in this case? Have the answer? Let me know. If you have the answer, do let me know. Hello, are you with me? No, I already described. See, first of all, you have to realize that this is a linear relationship. Do you understand this is a linear relationship? Do you understand that this is a linear relationship? Because for constant changes here, see 1 plus 1 plus 1 plus 1 plus 1. Correspondingly, this is plus 2. plus 2 plus 2 plus 2 plus 2, right? Now, what is the logic? Your linear expression will always be in the form y is equal to mx plus c. Your linear expression will always be in the form of y is equal to mx plus c. Your c value is the output when input is 0. Right? So c value is nothing but check. Input is 0, the output is 5. Your c value is nothing but 5. Got it? Yeah. That is what we did in the previous case as well. See, the previous case as well. 3. What is the significance of the number 3? The significance of the number 3 is the output value when the input is 0. The initial value. Yeah. What about m? How can you get m here? How can you get your m here? How can you get your m here? Yeah. M is nothing but change in y over change in x. Yeah. Change in y over change in x. What is change in y? Plus 2 by plus 1. Your m value is 2 over 1. Because, everywhere when the change in x is 1, the change in y is 2. Simple. Your y value is 2x plus 5. Your y value is 2x plus 5. Please check if it matches. Please check if it matches. Take some ordered pairs and check if it matches. Yeah. Prisha and Robin, yeah. Is that fine? Is it okay? I mean, you understand the logic, right? It's very simple. C has some significance, M has some significance. Okay, C has some significance, M has some significance. Okay, yeah, M is nothing but delta Y by delta X. Okay, suppose you have two set of ordered pairs, like say two set of input outputs, your X and Y. Suppose you have two particular values of input and output. One input output pair is x1 and y1. Another input output pair is x2 and y2. How will you find the slope? How will you find the slope? How will you find the value of m? How will you find the value of m? By finding, yeah. How do you calculate that? Change in y by change in x. Change in y is nothing but y2 minus y1. When you're going from y1 to y2, the change is y2 minus y1, the difference. When your input goes from x1 to x2, when input goes from x1 to x2, what happens? The change in x is x2 minus x1, the difference. Okay. So your m value is nothing but difference in output by difference in input. Do not forget this. You would have already seen this, but rather than just mugging up the equation, rather than just by hearting the equation, please understand what it is. What is the significance? Okay. What does it signify? In a physical sense, what is the meaning? Okay. And next class, we'll see the geometrical significance. We have not gone to the geometry part yet. When it comes to geometry, it has some significance. It represents a straight line. For a straight line, there is an x-intercept, there is a y-intercept, there is a slope. And that things we have not discussed yet. We are still discussing about the equation and its physical significance. Okay. And the physical significance we have already seen. The value of C is nothing but the output when the input is 0, or the initial value of the output. And value of m is nothing but the change in y over change in x, which is nothing but rate of change, of the constant rate at which your y value changes with respect to the x value, right? Yeah, the physical intuition is clear, right? Hope it makes sense. Yeah. Yeah. Okay, cool. Anyway, I'll share a problem sheet with you for this week. And in the next class, we'll go to the geometrical significance. For the time being, we're discussing about the physical significance and the mathematical significance. Next class, we'll see the graph of linear functions. What is the significance of m? What is the significance of x? And then we'll move on to straight lines. I hope you have already studying straight lines. But again, we'll see all this from scratch, okay? Next topic after graph of linear function will be straight lines. And then we'll see pair of linear equations, okay, in two variables. Pair of linear equations in two variables, right? Okay, then see you in the next class.